Okay, hello again, Algebra 2 students. Recap of video number 1. By the way, I lied to you guys. This is going to be 3 videos, not 2 videos. Okay. Video number 1, we did an exponential growth function. So we graphed f of x equals 2 to the power of x. We made a t-table. We saw our y-intercept is at 0, 1, and we saw that it goes up, it skyrockets up, shoots up like a rocket, like a jet or a rocket, whatever. Okay, but we noticed that the more we go to the negative, it got so close. We were getting 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32. It was getting so close. But our y value was never actually getting to 0. It was getting so close. 1 over 2, 300, 400 something, 500 something, 1,000 something, but it was never actually getting to 0. That was called an asymptote. Y equals 0 was our asymptote. Asymptote's hard to spell. Anyways, y equals 0 is our asymptote. And the reason y equals 0 is our asymptote is because, hey, if I make this 0, if I make the y 0, that's impossible. It's literally impossible. 2 to the power of nothing is going to give you 0. It's not mathematically possible. So that is called an asymptote. That means you're never going to touch that 0. Okay? So I want to do something different this time around. That was the first video. Okay, the second video, I want to do this. This is the exponential growth. I'm going to erase this growth right here because we're going to change this. I'm not going to tell you what it is just yet. And I'm going to change this to, I'm going to change that to a 1 over 2. Okay, I'm going to make it a fraction. It's going to be a number less than 1 in this case. Okay, absolute value is less than 1. So here's what we're going to do. Just like last time, we're going to make a t-table. Okay, this t-table is going to be a little more complex, but we can still do it, okay? First and foremost, 0. Let's try 0. And then I'm going to actually, I'm not going to redo it. What I'm going to do is I'm going to do this in a different color to make it a little more clear. Let's do this one in purple, okay? So, 0. What that means is 1 over 2 to the power of 0. Anything to the power of 0 is equal to 1. 0, 1. 0, 1. Hey, look at that. Same spot. Cool. Same spot. Now let's do 1. Here's where it gets nice. If I do half to the power, 1 over 2 to the power of 1, that's going to give me half. So at 1, we have half. Starting to look kind of interesting here, okay? Looks kind of interesting. Let's try now 2. Okay, so 1 gave me half. Now we're going to plug in 2. Let's see what happens with 2. Well, half to the power of 2, anything to the power of 2 means that times itself. So 1 over 2 times 1 over 2 is 1 over 4. Easy. 1 over 4. 2 will give us 1/4. So 1/4 is like what? Like right here. Okay? Again, not perfect, but it's the best I can do. So let's follow this logic. 3. Well, power of 3 would mean half times half times half, which is 1 over 8. So that's going to give us 1 over 8. And I'm just going to continue the rest. Just going to fast forward it. 4 will give us 1 over 16, and 4 is going to give us 1/16, which is really close to 0, but it doesn't quite hit 0. 5 is going to give us 1/32, which is really close to 0, but not quite 0. Then 1/64, really close to 0, but not quite 0. So you guys get the point. It's going to be going down like this. It's going to be going down like that. Now, what happens when we go to the negative? Well, let's think for a second. You can already kind of tell this original one, the one I did in black, was our exponential growth, 2 to the power of x. Now I'm doing half to the power of x. But if you notice, as we go to the right, what's happening here is actually going this way. Not touching 0, though. It's never going to touch 0. Let's see what happens on the left. So now I'm going to try plugging in. I'm going to try plugging in with negative numbers. Let's try -1. So half to the power of -1. Now remember, negative exponent, it flips. Okay, so it flips this fraction. It's going to flip it, reciprocal. Okay, so let's think about this. It's going to flip it. 2 to the power of 1 is just 2. So this is 2. So the answer is 2. Okay, let me try -2. -2. Again, let's do the same thing. Let's flip this fraction. It'll be 2 to the power of 1. But then we do to the power of 2. So 2 to the power of 2 is 4. That's just 4 over 1, which is just 4. So if you follow this pattern, negative 3 would be 8. Negative 4 would be 16. And so on and so on. Negative 5 would be 32, and so on and so on and so on. So I'm going to graph that. Negative 1, 2. Negative 2, and 4. Okay, erase this. Negative 3, 8. I think you guys are starting to see what's happening here. It's like, look at that. It's like a reflection of that one. Negative 5, and then all the way up here. So what's happening is this one's coming down like that. Let's look at this from left to right. From left to right. Starting up really, really high, and it's doing a rapid decline. It is free falling down, and going down here, but never quite reaching 0. It will never actually touch 0, but it is free falling down. Okay. Sometimes I feel like my money is like that. Okay, it is just going down, 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 down. I never quite reach 0 because I always have a little bit of money, but this is called an exponential, not a growth this time. This purple one is an exponential decay function. That is an exponential decay function. And the reason we know that is because of this. Is because I look at this and I notice this is a fraction. It's not just any fraction. It's a fraction less than 1 is really what it is. Okay, so I know that's going to be decayed because if you take a number more than 1, let's say 3, you go 3 squared, you're gonna get 9. 3 to the power of 3, 27. See how fast it went up? 3 to the power of 4, 81. Oh my goodness, that goes up really, really fast. But if you take it and make it a fraction, which is less than 1, so let's make that 1 over 3. You square that, you get 1 over 9. Oh, that's tiny. That's not 0, but it's pretty close to 0. 1 over 3, and you raise it to the power of 3. You get 1 over 27. Oh my goodness, 1/27? That's a tiny, 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 tiny bit. Make that 1 over 3 to the power of 4. You get 1 over 81. That is microscopic. I mean, we can't graph that on this graph. It's so small. It's so tiny. But it's not quite 0. It's really close to 0. So that is called an exponential decay. If you take a fraction and you raise it to a power, it's going to get smaller and smaller and smaller and smaller. So that's what the kind of point of this. That's what I want you guys to understand. Now, I am going to do one more thing to this, okay, guys? And actually, we have time to do it. So maybe we'll just keep it at 2 bits. All right. So I'm going to erase this. I'm going to erase this exponential growth, the exponential decay. Sorry, I'm only going to keep the growth here. Exponential growth. Going back to what we did in video number 1. And exponential growth, if you remember, was 2 to the power of x. That was the one. Okay, we have our asymptote there. What would happen if I do, let's say, something like this? Plus 1. Well, what you guys know from previous functions that we've done, when I put a number there, plus 1, minus 7, plus 3, whatever, it shifts. It's going to shift this graph. Well, which way is it going to shift it? How is it going to shift it? Well, let's find out. Okay, everything is going to be the same here except, watch, if I plug in 0, 2 to the power of 0 is 1. Anything to the power of 0 is 1. Plus 1 is going to give us 2. Let's make it a 1. 2 to the power of 1 is 2. Plus 1 gives us 3. Let's do 2. 2 to the power of 2 is 4. Plus 1 gives us 5. 3. 2 to the power of 3, 8 plus 1 gives us 9. Okay, so I'm going to start graphing about this forever and ever and ever. I'm going to do just one ingredient. 0, 2, interesting. 1, 3, interesting. 3, 2, 5, wow. 3, 9. Okay, so what you're noticing is it's just right above it. So it's the same graph, the same exponential graph, but it is just slightly above it. How much above it? It's exactly 1 above. That's exactly what it is. So everything's being shifted up 1. So I'm going to shift everything up 1. Move this up 1. Move this up 1. Move that up 1. Move that up 1. Move that up 1. Everything gets shifted up 1. But since everything gets shifted up 1, what else gets shifted up 1? Our asymptote. So asymptote's no longer on 0 anymore. Our asymptote, sorry, this is crusty. Our asymptote is at 1. So that means this curve comes here. So where is it at 1? That is going to be at y equals 1 is our asymptote. Y equals 1 is our asymptote. That's what it is. Okay? That is. So if I say y equals 1 is an asymptote, what I'm telling you is y cannot equal 1. Impossible. Y cannot be 1. Let me prove it to you. Y cannot be 1. Let's see if that's true. Here's my y. F of x is y. I'm going to make y 1. By the way, this should not work. I'm trying to show you that this is impossible. I make that y 1. Let's solve this equation. Minus 1, minus 1. 0 equals 2 to the power of x. And automatically wrong. We're done. That's it. Can't do it. 2 to the power of nothing is going to give us 0. That is impossible. That's an asymptote. We just found an asymptote. Okay? So we cannot make y equal 1. So basically what we did is we just shifted that asymptote of 1, and the reason we know that is because it says plus 1 here. Now let's say I had, instead of plus 1, we had done minus 3. Simple. That asymptote now would be shifted down to negative 3. The asymptote would be all the way down here, but it would still be the same exponential growth. It would just be shifted down there. Okay, this video is getting kind of long too. This is about a 12 and a half minute video as well. Those are the basics you need to know for exponential growth and exponential decay. Okay, when exponential decay comes like this. So exponential growth, okay, and exponential decay, like a roller coaster coming down really, really fast. I understand this is not probably it's not the easiest concept to keep in mind. I'm going to flip this over so I can show you guys the homework. Only couple problems right here for this YouTube homework. But please, you guys do know that Thursday, 3 p.m., Algebra 2 tutoring. And those of you who have been there at the Zoom meeting Thursday at 3 p.m., you guys do know that we give you what's on the test. I mean, we're telling you straight up, this is what you need to know for the test. So as much as I like to say it's not mandatory, it's a tutoring session, come if you need to. I really recommend you do come because the people who are coming, I've noticed that are definitely scoring better on the test. I mean, just simple as that. Okay, so you just have 2 questions. Oh, this was calculations. Okay, so you have 2 questions. Again, this is for my pre-calculus, so don't worry about that. 2 questions. Number 1, graph f of x equals 3 to the power of x. Now, there's a few things I want here. I want a t-table here, 0 positives and some negatives. Y-intercept, equation of the asymptote. Now, just a little hint. Equation of asymptote for this is always going to start off with y equals something. Equation of asymptote is y equals something. So if the asymptote is at 0, you can't say, oh, the asymptote is 0. It doesn't mean anything. Y equals 0. Later on, you'll see graphs that the asymptotes aren't on the y or on the x. So it'll be like x equals 0 or x equals 5 or whatever. But I'm just letting you know for these ones, it's going to be y. And then this one's just a little bit more complex. It's 1 over 3 to the power of x. And then it's going to be minus 5. So that's going to be shaken up a bit. Try your best.